This video is for section 5-1, probability distributions. And what we'll do with this is we will define a discrete probability distribution, look at the requirements, and we'll also briefly run through example 2. All right, so first off, the definition of a probability distribution or a discrete probability distribution. And you'll see it there in your notes and on page 267 in the book. A discrete probability distribution consists of the values a random variable can assume and the corresponding probabilities of the values. The probabilities are determined theoretically or by observation. Okay, in plain English, what that boils down to, much like what we did back in chapter 2 with frequency distributions, we're going to put the data in the table. The table's going to have a specific format. And we'll see that in just a second when we get to example 2. Now, requirements for a probability distribution. And this is pretty straightforward, should make sense to you. There are only 2. And they are rules based out of classical probability. The first rule is the sum of the probabilities of all events in the sample space must equal 1. Now, if you stop and think about it, that should make sense. If I have listed all the possible outcomes, then the total probability should be 1 if I'm working decimal, or 100% if I'm working in percentages. The second requirement, and this one's not a big stretch either, the probability of each event will be between 0 and 1 inclusive. Again, thinking of the rules of probability, we can't have an individual probability that's less than 0. We can't have an individual probability that's greater than 1 if we're working in proportions. If we're working in percentages, can't be less than 0%, can't be more than 100%. All right, so nothing should be too crazy there. Now, if we look at example 2, which is actually drawn from the book, build the probability distribution for rolling a single die. And if we look at example 2, what we're going to do is we're going to put this data into a table. The first row is going to be labeled outcome X, and it will be then a list of all the outcomes. So in this case, we're rolling a single die, assuming a 6-sided die since it wasn't specified. So the possible outcomes are 1 through 6. We're half done. Second row and final row will be the probability, or the P of X, for each of those events. Now, if we think about the probability of rolling a 1 on a 6-sided die, classical probability, sample space, 6 things can happen. One of them is a 1. Run through that same logic for each of the other 5 opportunities, and you have your probability distribution. Now, if you think about it, this will meet both definitions. Each of these probabilities is a valid probability. 1/6 is clearly between 0 and 1. If you don't like fractions, you immediately went to decimals here. You'd have 0.167. The second part then is if you sum these, you should get a total of 1. Well, if you're working into fractions, 1/6 plus 1/6, do that, add up the 6 of them, you'll end up with a total of exactly 1. If you add up the 6.167s, you're going to have a minor issue because of rounding. You're going to come up with 1.002. Those 2 thousandths is just a rounding issue, and that's fine.